So now we'll take a look at another program called multiples. It's on page 152 of your book. And multiples, let's see if we can do something about how this looks to you. There we go. All right. So multiples, first we're going to import some methods from the scanner class because we'll have some use for those. According to our programmer, this is going to print multiples of user-specified numbers up to a user-specified limit. Okay, let's find out. Here's our main method. We have a variable that we're declaring. The name of this variable is per line. Nice underscore there, all capital letters because this is going to be a constant. Nowhere in this program are we going to change the value of per line, so we put the reserved word final in front of this variable declaration so we know it's a constant. However, we are going to have some variables. We're going to have a value, limit, mult, and count. Count's going to be initialized as 0. The rest of these, we're just telling the computer to reserve a certain amount of memory for integer values. We're going to instantiate a object from the scanner class. We're going to call it scan, and we're going to get our input from the keyboard. We'll ask the user for a positive value and pick it up from the keyboard. We're going to ask the user for an upper value, and we're going to pick it up from the keyboard. We're going to print a blank line here. And now we're going to print out the line. Let's see what's going to show up on the screen. The multiples of, and then whatever they typed in for value up here when they were asked the question. Then the word between. It's a literal string between two sets of quotes. Then another variable. Every time we run this, that variable is going to change. Then another literal string. Then a variable, limit, which we also ask the user for. And then another literal string, inclusive. That's going to include those two numbers, are. And then. Here we go. So here's our for loop. Initialization. Now we've already declared this variable mult. There it is. We already declared this variable mult, so we don't have to declare it again. And here we're going to use it in the variable, in the for loop rather. And we're going to initialize it with the number value, which is the very first number somebody typed in. Enter a positive value. First thing the computer's going to do is check to see is mult less than limit, and if mult is less than limit, the two numbers they typed in, then we're off and ready to go. Mult, notice in this example, mult isn't going up by 1. Mult is equal to mult plus whatever the value is. So it could go up by 5s, it could go up by 3s, it could go up by anything. We're going to run this program in a minute and see an example. So the next thing we're going to do is we're going to print, not print line, not go to the new line, but print mult, and then we're going to tab over. Then we are going to increase counter by 1. And then we're going to, oh that's right, counter was set to 0 in the beginning, so now we're going to increase counter by 1. So this will be, let's see, at first will be 1. Modulus is the operator, so we're going to divide by, let's see, we're going to take count and divide it by per line, but we don't care about the answer, the quotient. We care about the remainder. So let's see, 1 divided by, what's this, 5? Okay, so 1 divided by 5. 5 doesn't even go into 1, so the remainder is 1. Is that equal to 0? Nope, not at all. So we're not going to do this line right here. That is, we're not going to the next line. We're going to stay on this line. Here we go. Increment mult is less than the value. If it is, then print it. And then increment counter. And then keep doing this. And every so often check is count, whatever count is, divisible by 5. Well, let's see. 1, 2, 3, 4. Well, it's not till we get to 5 that this is going to be true. So let's imagine we've gone through 5 different system out prints here. Count equals 5. Okay, 5 divided by 5 would leave no remainder. So that would equal 0. And then we're going to run this line, which will finally take it to the next line. So in other words, all the output so far has been on one line until 5 divided by 5 has no remainder, and then we go to the next line. And then we're going to do it again. 5 numbers in a line, new line. 5 numbers in a line, new line. Actually, why should we guess? Why should we guess about that? Let's go take a look at that. No, not that one. There we go. Let's go take a look at multiples. Let's make sure I got the right program first. Multiples. Yeah, that's exactly what the other program was. Let's take a look and see what this. Oops. Let's take a look and see what this thing does. Should have cleared this first. I think I will because I got some other things going here. All right, off we go. Multiples. Oh, it's running. Okay, it's going to ask us for a first number. So I'm going to type in a 2. Then it's going to ask us for an upper limit. I'm going to say 50. And notice the program's going to spit out the multiples of 2 between 2 and 50 inclusive. In other words, 2 and 50 are included in this list. You know, just for the heck of it, I think I'm going to run this thing again, just so I see if I can get it right this time. And enter a positive value. I want to enter a 5 this time. Hit enter, an upper limit, let's say 90. So the multiples of 5 between 5 and 90 inclusive, including those two numbers, are, and notice I have 1, 2, 3, 4, 5. It was a constant in the program. 5 items per line.